So so I take a team when the competition is running, which it wasn't during COVID, but they are running in the spring this year or next year. I take a team of students to England to compete in a Raspberry Pi based robotic competition. So that's just quick who I am. I didn't really want to get into all the history and background and stuff like that. I just rather kind of jump into the content. So what I want to do, let me share the screen and get things arranged. Make sure I have the chat up. And I got video there. And we're working on separate screens, so that's why I always looking off to the left. So I'm not a big presentation anymore. I like the used to all you ever used to do. But so we have some of this, so we have at least a blueprint of what's going on today. So this is getting started with the Raspberry Pi Pico. And as far as agenda, right? So there's only one set of slide decks out there. If you've taken a class with me before, you kind of know how I operate. If you haven't, and you like structure, I'm going to apologize up front. There is structure, but it's not a printed structure. So I want to make that note right off the bat. So in my workshop, so basically I have an idea of what we want to get done today. Obviously, if there's interest that goes a different route and it fits into what we're doing, we'll go ahead and take that trip down the rabbit hole kind of a deal. I find that a lot of times those are where we get the most interesting learning that happens. So the idea of this is that tonight, once we're done, I'll kind of evaluate how the day went and how far we got. And from there, then I'll put together what I want to get accomplished tomorrow. We do have a plan, I do have a plan of stuff I want to get done, but I also don't want to have it pigeonholed so much so that if there's an interest that the group has, that we can't go that route. And I'm comfortable enough with the technologies and things like that we could do that. A lot of the labs that I do with my classes, I do them live without practice, and I do them without reading the instructions beforehand in order to give them, the idea that we can troubleshoot as we go. So, so I just want you to be aware of that, right? So for those that really like ABC, this is an AB, B2, B1, C4 kind of a thing, right?
Hey,
but we are,
Garrett,
yeah.
I'm sorry, I came in late. So I've got all the materials and everything, and I don't know if you said this when the course first started, but do you want us to start downloading the micro Python? Okay, no, not yet. Okay, all right.
Yeah, we'll do that together.
Okay.
We'll do everything together, and then there's some of you that are, and I haven't asked this yet, but there's some of you that are probably, more talented with these things. You've played with these things before. You're comfortable with Python. You're comfortable with microcontrollers, and you're here to kind of see why the Pico is different. And once we get rolling, if you want to take off and do more things and experiment with other things, I'm okay with that. That's perfectly fine. I don't have any issue with that. It doesn't offend me. Right? This course is designed to kind of be a primer, right, for the first couple of days, and then based on where everybody's at, we can then kind of go into a bunch of different places, right? So the Pico, which we'll talk about, I think step 3 here, step 2 maybe. But the idea of the Pico is that it is it's a microcontroller, but it also has some capabilities. Like you can do TensorFlow on it, you can do web pages on it, you can connect it directly to the internet if you have the W version. So there's lots of things that we can do with it, which that'll be kind of the back end of the workshop. That help?
Yeah, thank you.
No worries. Awesome. Okay. So today we're going to talk about, we're going to introduce the Pico for those that haven't or aren't familiar with it. We'll talk about why use the Pico, like in this, specifically, this is from a teaching perspective, why I use the Pico. And we'll kind of look at some of the alternatives that are out there. The one thing I do want to point out before we get started, I'm not advocating that the Pico is better than other things. There's all kinds of really cool products out there. And Arduino being the biggest of the microcontrollers. So this is not a Pico's better, Arduino's better kind of a conflict. This is just, let's just play with this new microcontroller and see what we can do with it. Okay. We'll talk about resources. For those that are familiar with my workshops are resource intensive. By the time we get done, we'll have probably a document of, and I would expect in this class maybe 5 or 6 pages of different web pages that we can use, or that we can refer to, or that we can gather information from in order to maybe integrate a Pico lesson into class. We're going to talk about, we're going to set up the Pico. Right, so get that thing, get it set up and get it talking to the computer. We're going to set up MicroPython. In our case, we're going to use Stani to connect to the Pico, and then we will do a couple of lessons. There's a MicroPython lesson, real simple, and then we'll start getting into the physical computing and getting LEDs and buttons and things turned on, and then we'll see how it goes. But that's kind of the basic plan for today, is to kind of get through those components. All right. So some thoughts on how to make this an enjoyable experience. I tend to go on and on. I'll just keep talking and we'll keep playing, and then somebody will remind me, hey, we just missed lunch, kind of a thing. So I don't do that on purpose. It's just, a lot of the kind of hard to not have fun with what we're doing. I do have this kind of fun clock. I don't know if you've ever seen this thing right here. You can turn it to, like, I can turn it there, and now I've got a 60-minute timer going. So, and we'll leave that timer running. So that'll tell me that, hey, in 60 minutes, we need to stop, right, and take a break. So we'll try to do that so that everybody, right, you can, answer emails, go to the bathroom, get some food, get some more coffee, whatever the case is. If you have questions, right, use it in chat. You can raise your hand. I've got those off to the left, so I may not see them right away, but I have those information there. If for some reason I'm not seeing those and you need to interrupt me, just, as I pause, interrupt me, right? No problem. If you need to if you need to step out and take care of something, just do it. I'm recording. Thanks to Mike for reminding me to record. So if you need to go back and do that, so at the end of the day, so I'll record till lunch, and then I'll stop that recording, then we'll start again after lunch, and then those will be 2 separate YouTube videos that'll go post on my YouTube channel. So you'll be able to get to those later this evening. So you can go back and watch if you had to leave for something and take care of it and come back. If there's something interesting in that gap, you can easily go back to that. This is also a hands-on workshop, right? So hopefully we find our kits. But the part of the thing that makes a hands-on workshop fun is actually doing the hands-on, right? So kind of boring if you're just watching and not trying to do anything. And I tell my students in my class, try all the activities, right? Ask questions. If something's not working, like, let's figure it out. I want you to experiment with things, try to do something different than what the actual instructions are saying. It's perfectly fine to break stuff, right? If something doesn't work, that's fine. We'll figure out how to make it work. My hope is that when we're done, like, you get some enjoyment out of playing with the gear. You've learned some, if you don't know Python, or you've learned some Python, or you learned how this microcontroller works differently than other microcontrollers, that kind of thing, right? And then maybe you've generated some ideas for your classes, right? To integrate these into classes. All right. So the Raspberry Pi Pico, we're going to jump out to their product page real quick. And I was going to grab, let me fire up one other item here. I have a top-down projector so we can actually or a document. Move that off to the side while it launches. But so this is the Raspberry Pi Pico. Really want to kind of show you size-wise what we're talking about. So once the camera launches, we'll get that showed up here. And then, so let me ask, like, so in chat, who's familiar with the Pico? Who's actually played with the Pico or Arduino? Like if you've ever played with microcontrollers. Cool, not really, that's good. A little bit, all right. All right, I like it when we don't have some Arduino, but not the Pico. Okay, a little, none for me, none. So, all right. And so that's the answer to the first question, right? So on the Pico side of things, how about Arduino? Has anybody played with Arduino? Trying to figure out where I have a Raspberry Pi that's really easy to get to. All right. Nice. So when you say micro data center, did you do them in parallel or did you use them like individually where they were all individually running? All right. So this is okay. Awesome. Okay. I love it. Good. Well, it looks like we don't have a lot of experience with anything microcontroller based. So that's actually, and that, and for the most part, everybody's in that same boat. So that's really cool. If you do have experience, right? The first couple days are for sure just, getting us started, and just basic understanding. So they may be a little slower than you would want. If you do have experience, right, there'll be opportunities for you to do a lot more or extra beyond what we're doing in class while we're doing class.
Can I ask a question?
Yeah, absolutely.
So I bought the W, and I guess the headers were soldered on by another company before, but I was kind of just curious about what the difference between the W and the WH are the headers like soldered on by the factory in the WH?
Yes.
And, okay.
Yeah, but you essentially have a WH because there's the headers on it. But it's yeah, because like, I know Vilros will do that. And then if you buy, there's a couple different manufacturers on Amazon that'll do the header soldering. I have my students buy the header soldering, so I don't have to show them how to solder.
Okay.
That just gets beyond what I really want to teach in the class. Like, that is not what that class is about. So
okay. Yeah, that's kind of what I thought it looked like, is that somebody maybe had done the soldering already, but mine already have it on there. So
great. I love it. Hey, Richard.
Hi, everybody. Hi, Terry. I just wanted to pop in, say hi, welcome to everybody. And I see many of you don't have much experience. I'm in the same boat with the Arduino and the Raspberry Pi and everything. You're going to learn a lot this week, that's for sure. And if you sign up for week number 2, you'll learn even more with Carrie next week. So anyway, just wanted to let you know that it's really important that you come into Carrie's Zoom meeting each day through the Engages platforms. You need to go to the event, go to the workshop, because that way we can collect your attendance and participation hours. It's going to be important for your digital badge that you'll earn, and also for any professional development credit that your school might give you credit for. If you put in, close to 30 hours this week. So we want to make sure you get that credit too. Anyway, have a great day. We remember Wednesday at lunch is our raffle run, but that's lunchtime Pacific time out here. So just make sure you keep track of that, and you'll go visit every one of the sponsor event booths or campsites, I guess we could call them, and see what you might win. So anyway, have a great week. Carrie, thank you so much again, as always.
Pleasure.
And I know everybody's going to have a good time here. I think you might have a few that are not in yet, a couple stragglers that might be coming a little bit later.
Yeah, I think we have
We're
11 here with you and me. So
okay.
I think we're
Sounds great.
almost there.
Wonderful.
I love it.
Have a great time. I'm going to be scoping you guys out.
Nice. All right. Okay. So there is a question, right? And we'll get to that question, Tina, shortly. We're almost there, I promise. Okay. So good. So how about Raspberry Pi? I want to ask that question, right? So Raspberry Pi, because this is a Raspberry Pi Pico, and a lot of people may or not get confused with that. Have you used or are familiar with the Raspberry Pi? Like everybody, if you can answer. All right. So Kevin. So yeah, and I know Mike is. So Lee, no. So this will be probably, I would guess, about half and half with the yes and no's. All right, so a little bit exposure, yes. Okay, yeah, so half and half or so. Okay, so I think you see the Pico on the screen, right? So the Pico is this little device right here. This is the Pico, right? So this is the Pico here. And when we talk about headers, these are headers, right? So these little pins are headers. So this device, if we look at the picture here, right, this picture here, we can, this right here, the base device, the $4 version of this Pico doesn't come with headers, right? So what we mean by headers is they've actually soldered these headers, and you can see, let me get this closer and show you, right? So you can see the soldering, right here, all of this little silver stuff here. So this basically, this header piece, this metal, these metal headers, right? These metal pins, they are pushed up through the board and then soldered on top to make connections with the device itself. What that allows us to do is to take a breadboard, right? Which is a way for us to do electrical connections without, you can kind of see if we get it in the right angle, you can see the little shiny of metal inside of the holes. Sometimes it shows right there, you see the little metal, right? This allows us to actually press this into the board. And then, for example, if I wanted to connect to that first pin right there, I could plug something into this hole and they would actually make an electrical connection. So that's why we use the headers, because otherwise you actually have to then come up with some way to hook a wire into this to make it permanent. Otherwise it'll fall off, right? When you're trying to do your circuit, right? So we use the headers so that we can mount the board. Refocus that. We can mount the board here to a breadboard, and then we'll use wiring to connect to LEDs and other things, right? To get an idea of the size of this, if you're familiar with the Raspberry Pi, this is a Raspberry Pi. Okay, so it's really small. If you're familiar with Arduino, right? This is an Arduino Uno. Okay, so you can see that it's a lot smaller, right? And these two have real similar capabilities. But this is a lot smaller package, typically less expensive. This is an Uno. This Uno costs, I want to say, depends on where you get them from, $15 to $30. This one is the SparkFun. This is the SparkFun version of that. So this and this are the same thing. They're all microcontrollers, and we'll talk about what a microcontroller is in a minute. But this chip here and this chip here do essentially the same thing, right? This chip is a lot less expensive than this chip, but this one is, obviously it looks like it's cleaner, but they do the same thing. These two do. So from a size standpoint, right? So tiny, pretty powerful, lots of cool stuff. Okay, just want to make sure we understand like size, different things like that, and then we can go into more detail. All right, cool. So does that help with the header and the soldering question? Make sure that we got that understood.
Hey, Carrie, I had just a real quick question. Is it safe to just handle them by the edges like that to not worry about static?
Yeah.
Okay, thanks.
I've always, yeah. So like even on the Raspberries, I hold them by the edge. I mean, I don't touch the circuits as much. And I try to use I'll use So I have this is the tool that I used to have from when I did a lot of low voltage cabling. So this is the tool that a lot of telephone folks will use because we can push the wires into the connectors that way. So I use this to kind of point things out. So if you're, if you have some kind of a pointer, if you're doing this where you're going to show people, I mean, I don't want to sit there and touch the chips. But in the most cases, right? So if you handle by the edges, you're going to be in good shape. I've had students. Sorry, I've had students short out their Raspberry Pis, but not because they were touching it, because they crossed wires on the pins, right? So the one thing we do need to be careful with, right? So we really don't want to have this powered up and then touch wires across these pins, because like this is a 5-volt pin, and if I touch it across this other pin, it's gonna create problems in my circuitry, mess up the circuitry, break the machine, that kind of stuff. Same thing with the Pico here. Problem is not really a problem. We're going to actually bury all the pins into the board, so it's really hard for us to to cause problems crossing pins with that. All right, need to get a drink of water. All right. So no worries. Good. All right, so there's a couple of examples here, right? So this is physical computing here. So this is what I'm talking about, and what we're actually going to create this contraption here later. Probably not today, maybe first thing in the morning. This is a stoplight, right? So we're going to actually create a stoplight and program the stoplight, and you'll wire it up, and we'll talk about all the different pieces and parts of how to make that happen. So we're going to do quite a few physical computing activities. And what I mean by that is we're going to create, we use buzzers and buttons and lights and other devices to make things, right? Physical devices. There's other things that you can do with it, like we talked about a little while ago. You can with the W version. So if you have a W version, you have this little heat sink. As you can see how this one and this one are different. This is the original Pico. This is a W. This is going to house the Wi-Fi. The chip that does the Wi-Fi is in here, and the antenna is in there. All right. Right, so we can use it for light displays. We can use it for signage, right? So you can actually use it to make digital signage. You can actually send stuff to it and have it control what's going on the boards. We're going to use it for a bunch of different things, right? One of the cool things about this is programmable in C and C++, and MicroPython. I think we can add Rust to that. And there's one other. Oh, we can do Arduino IDE using this. So it's capable of doing quite a few things from a programming standpoint. So you're not limited to Python. You can do a bunch of different stuff, right? And then with wireless, and then you can get them with headers, which is what we've talked about already. So this chip is, or the processor is based on a chip. The chip is called an RP2040. It's a chip that was created by the Raspberry Pi Foundation. They created a chip. They actually created the silicon, and then they allow other folks, other companies, to actually buy the chip and create their own RP2040 20, 40 devices, right? So not only does Raspberry Pi create these devices, but you can also get them from like Adafruit and SparkFun and some other manufacturers out there. And we'll go through that list of companies a little bit later. But there's a lot of variety of devices, so people can customize these. Using that chip, they can customize the device to do something specific. Like, so there's some real specific ones for TensorFlow. And TensorFlow is an AI machine learning tool. So I think there's TensorFlow ML, it's a small version that fits on this. Obviously, this is not a super supercomputer, but it does quite a bit of stuff. So it uses the ARM for Cortex M0 Plus processor. It's got 264 kilobytes of internal RAM, and it can hold, or it can support 16 megabytes of off-chip flash. So I don't know. I think there's flash. This one has flash on it. It also can do some other things. So from a input-output standpoint, right? So we talked about those pins earlier, right? So those pins on the bottom of this, right? Those are all general purpose input-output pins. Some of the pins provide power, some of them provide ground, some of them are programmable, right? So I can turn power on or turn power off. There's also some other communication capabilities that it has, I2C and SPI, which we will probably get to later in the week, but those are more advanced serial communications that allows us to actually daisy chain devices attached to the Pico. So we'll be able to do some fun things with that as well. Okay. So a microcontroller. So if you're not familiar with microcontroller, a microcontroller is a device that we typically are going to connect sensors to, right? So it's a device that we can program, and we're going to connect sensors to it. And microcontrollers are going to typically gather data, right? So they're going to gather data. Sometimes they have the capabilities of doing things with the data. So in our case, like we'll have it collect data and we'll have lights turn on because of a button was pressed or things like that. But a lot of times you'll see microcontrollers in devices in order to make things happen. So repeatable things. So coffee makers, have microcontrollers in them to run, do the things that they need to do. Your refrigerators now have microcontrollers in them, right? So a lot of like laundry, washing machines, dryers, things like that are going to have microcontrollers, not specifically a Raspberry Pi microcontroller, but a microcontroller. And the idea of that is I can program the microcontroller to do something specific, and then it just follows the rules, right? And that's all it ever does. It just follows those rules and does what it's told to do, right? By adding wireless capabilities, we can now take that sensor that was, maybe it's a temperature sensor, and we can have it share that data with other devices like Raspberry Pis or, a service online like IFTTT, and have that create other events. So say maybe, so one of the ones that we like to do a lot in the IoT class is we use a light sensor, right? So it's a photo sensor, right? So it can tell the amount of light. And as the light drops below a certain point, we call that sunset. And I'm about to sneeze. All right. That light, once it drops below, it triggers an event, right? It triggers sunset. And then sunset, when that trigger event sunset, then we can use the wireless communication to connect to an online service that will then trigger an event to happen on your Google Calendar, right? So then your Google Calendar will list out when exactly sunset happened, right? And then the same thing happens in the morning as the sun comes up, and we hit a certain threshold. We call that sunrise, and that triggers another event, right? So that's what the idea of these devices are for us, is to create smart devices, right? To take things that are, and they're not really dumb, but like, let's take a temperature sensor. And we want to gather temperature sensor data, and we want to make it smart. So let's say we put a temperature sensor in a server room, right? and we want the temperature to be between 60 and say 72 degrees. Anything above 72, I want to be aware of. Anything above 80 or 90, I need alerts, and I need everybody on the IT team to know about it, kind of a thing. So we would set a temperature sensor in there, connect to a microcontroller. We would collect the data. The data, the program would say trigger at 72 to give the IT manager an alert that, hey, we're at the top end of our comfort range. And then at 90, or at 80, let's give everybody a call, right? So then somebody can show up at the server room and see, why are we not staying? Why is the room not cool, right? Right, and that's kind of the idea of these microcontrollers. If we can turn, a simple temperature sensor into a smart device and have it do, help us automate things, help us alert on things, right? Create, the whole Internet of Things kind of a set. Okay.
Carrie?
Yeah.
So if you had so the main difference between the Raspberry, just correct me if I'm wrong, please, but
yeah,
the main difference between the Raspberry Pi and this Pico is that you can actually have like a full-blown operating system. It's like basically a small computer already, the Pi is, right? But
right. Exactly.
And so if you were going to try to use this controller, would you have to have another you can just load it up with the software that you want and then it'll just run, but if not, you would have another computer hooked to it that would control it then too, or?
Yeah, so you can do, so this is the Raspberry Pi and this is the Pico, right? So the Pico microcontroller, I'm going to connect devices to this and have it, it's like a repeatable program. So the temperature sensor, keep the temperature. When the temperature, in this case, I could put an LED and say, when the temperature gets to 72, turn the yellow light on, right? And when the temperature gets to 80, turn the red light on, right? So and that's just a real simple microcontroller deal. Okay. With the W, if I have a W, which is this one, right? This has wireless. I can connect that to the network, right? So then I can have that same setup happening, right? Green if it's in range, yellow if it's getting a little bit out of range, and red if it's where I need to be alerted. At the same time, using the wireless, I could have that message, send that message, say, to a Raspberry Pi. So the Raspberry Pi, this computer here, this is a single board computer, right? And they're called single board computers because everything you need to run a computer is on this chip, right? So it has processing power, it has memory, and it has video, right? Those are the three components that it needs to have a computer to be a computer, right? In addition to those three things that are on this chip. So this is the same kind of chip that you're going to find in your smartphone, right? These are ARM. These are actually quad-core 64-bit ARM processors that are on these Raspberry Pis. Okay, there's memory and wireless built into these systems as well. The memory is actually on the chip. This is the wireless. Then this one has, right, so it's got Bluetooth and Ethernet, right? It's got HDMI video. It's got, audio. It also has, right, those pins that we talked about, the general purpose input output pins, right? And then this one also runs, the operating system runs on an SD card. I can load Linux onto this device, right? And we do that all the time. So you run an operating system on this. You can run a desktop, right? I can run servers on this. We have students, and we'll probably do this next week, but we turn these into wireless access points, right? So it has wireless. I can actually make it an access point on my network. You can run firewalls on this. You can do a bunch of things. These devices are a lot more limited. This has quad-core processor, gig of RAM, 2 gigs of RAM, or 4 gigs of RAM, depending on which version you get. This one has, like 256K, right? And maybe 16 megs of flash, right? So it's not, these are they're limited from the standpoint that they're designed to do something different, right? These are meant to, you program these. So you write a program, you send the program to the device, and then it runs the program over and over again until you either stop the program or you turn off the device, right? Raspberry Pi, it runs like a computer, right? So if I want to run a program on it, I can run a program on it, and it'll run until I stop it as well. But it's also running a desktop operating system. It's connected to the network. It's, you know, passing traffic on Wi-Fi. I can use it to collect camera data. There's all kinds of other things that can go on, right? So this is a computer. This is a microcontroller. So it's not, I mean, they both have similar features. This one here, we don't have any video output on it, right? You actually, we send the data to serial port, serial connectors, and we watch the data on serial connectors, right? I'm looking at the thing here. So if I'm running the Pico as a controller, how is it powered, right? Right. So it's stored either in the RAM or the flash that's on the device. So that's where the program is run. And as long as it has power, that program will run. So in fact, I think the right way to say that is if you name your program main.py, main.py, and you push the program, you save the program on the device, on the Pico. And we'll do that in a little while. When you power it, right? So I could power it with a USB cable from my computer. Okay, that's what this is. I can connect it to a battery pack. Okay, and it uses a micro USB, right? So any battery pack that has a micro USB output on it, I could connect it to it and run power. There is actually a way for you. I mean, you could, run it with a little solar panel to a battery pack. The battery pack's connected to that. There's ways of running this. Like, so if you wanted to make a compact device that say sits out in your yard and collects data, right, and it's in an enclosed component, you would just, either provide it with power, right, so run a line out to it, or you can, provide solar with batteries to make it work as well. It doesn't use a lot of power, right? So you'll be able to do a lot of things with it without having to run a lot of power to it. Okay. The second question. So I think I answered all of those, right? So it's going to be stored on the onboard memory, and you just power it with any kind of anything that you can push power through that device, through the micro USB. Wireless runs the Pico pretty comparable to a PC. We will find out later this week. I think it's going to be comparable. I know that the wireless that are on the Raspberry Pis are, I mean, they're AC wireless. It's good stuff. So, I think it would be similar in range. I think it's going to depend on, how big of the antenna can they, cram it that little bitty space. That little space is like, there's my right thumbnail size. Awesome. Cool. These are great questions. Sorry. All right. This book here, which is one of the books that was in the shared information. I'll show you how to get to it if you can't get to that. But this is the book we're going to use this week. It looks, I don't know if you can see my video or not. But it looks, it's a little, I don't know, 7x9 kind of a thing, 9x6. That's 180 pages long, 138 pages long. But it'll get us started with all of the different things that we're going to try. So that's a really good way to get started. This book is available free online. You don't have to have a hard copy. You can use the online version, and that's what we're going to use in class this week. For those that get more advanced, and this is more advanced than I've gotten on this, but they actually have a debug component. So on the Raspberry Pico, so this is something I have never had to deal with, but right here, these three little pins, right? You can actually, there's that little header that you can get, right? A little 3-pin header that you could solder there, and then you can connect a device to it here, and it'll actually do debugging, right? It'll actually help you figure out if all the components are passed in power the proper way and that kind of thing. So nothing I've ever done with my students where we have never gotten to the point where we need to worry about debugging to that level, right? So I'm thinking this is more of a, if you're going to use these Picos in an industrial standpoint or commercial standpoint, you need things to make sure that they're functioning 100% proper. You would probably use the debug component. Okay. And then they talk about how it's well documented, and we'll go over the documentation in a little while. But from an introductory standpoint, right? So that's the idea of this board. There's actually we'll go over kind of the details of the actual board itself, the specs. So what they were talking about earlier, just so that you're aware, right? They want you to enter. This is that engage. So you should have had this. I don't know if you, if some of you may have just gone from the link that I gave you. If you want to at some point drop off and go back in so you get the time credit and things like that, you might want to go ahead and do that. But you go to this engage.net, which you should have gotten an email that had that link in it, and then you just enter the class this way, and then you can click here to get into the Zoom link. And then right down here, link to course supplements. I believe this has all of the documents that we're going to use today. All right. And as we go through the week, we'll add documents here. I'll add them live to my regular Google Drive, and then at night I'll push more things to this particular drive. Okay. Actually, I think I can do it at the same time without having to mess with. They'll both be updated. All right. So just to make sure that have gotten that done and you know where to go and what to do with that. Okay. That was from just kind of Richard being here. I want to make sure that we're good. All right. So the next piece I want to do, let's kind of talk about the Raspberry Pi Pico. And let's talk about the actual documentation. So this is the actual documentation. This is actually going to show you the 4 different flavors. So this is the Raspberry Pi Pico. Okay. This is the Pico H, and you can tell the difference, right? If it comes from the manufacturer without the little gold tabs around the edges, right? That's a Pico H. Okay. That was because the headers were put on during the manufacturing process. Okay. If you, right, I think this one, yeah, so this is a good example. So this Pico here, you can kind of see the gold tabs along the edges, and you can see that the headers have been soldered in, So these were soldered after the fact. So I think it looked like somebody actually physically soldered these after the fact, right? So manufacturers are buying, or companies are buying these Picos, just the regular Pico, like in this case, this is a W, right? So they're buying the Pico W like this, and then they're paying somebody to solder them on, and then they're selling them. And right, even then they're still selling them for essentially the same price as what you would buy if it came right from the manufacturer. So they're buying these boards for, I don't know, $6 maybe, and then selling them for $14. So somebody's soldering those on really cheap. I guess that's how it is. All right, I got all kinds of drainage right now. All right, so Pico H, right? So the H is headers, right? That's what H stands for. This is the Pico W. This is the wireless version, and it doesn't have headers. And then the Pico WH, which is wireless and headers, right? So the hope is everybody got a hold of a WH as part of your kit or extra. I bought one the other day on Amazon. It cost $14, and it came the next day. So it's possible to get those, and they're pretty inexpensive. Like $15 for a wireless microcontroller is a pretty inexpensive price. Okay, we've already talked about the RP2040 being designed by the Raspberry Pi team. It is a dual core, right? So it's got 2 cores, Cortex M0 Plus processor running at 133 megahertz, 264K of SRAM, and 2 megabytes of onboard flash. Okay, so there's 2 megabytes of onboard flash on the board, plus the 264K of RAM. Okay, so we run all of our programs in 264K of RAM, and we have 2 megabytes of onboard flash to store programs on. It uses USB 1.1. It's got a low power, sleep, and dormant modes, so we can run into, you can actually set it up to run in low power mode. Drag and drop programming using mass storage over USB. So you create a program and you copy it to the device, and then reboot the device and the program will start running. All right. It's got 26 multifunction GPIO pins. Those are those headers that we keep talking about, right? So these headers here, 26 of these that are usable for general purpose input output pins. Okay, and we'll use a lot of those here in the next couple days. It's got 2 SPI, 2 I2C, 2 UART, right, which allows you to actually log into the actual device with wires. Like you can actually connect to it with wires. There's actually, I think I saw a tutorial on how to do that. I think that'd be fun to try. There's 3 times 12-bit ADC. So ADC would be analog circuits. They're actually analog and digital circuits, but that gives us 3 analog circuits, which the Raspberry Pi does not have analog circuits. And then there are 16 controllable PWM channels. So that gives us power with modulation. So what that allows us to do, so if you're familiar with digital, right? Digital has 0 and 1, right? Off, on. Those are the 2 things. With PWM, I can take that off, on, and I can create grades, right? I can create 1,024 grades of that. And I can control the amount of on and off, right? So it kind of turns a digital input and output into the results look like an analog output, right? I can actually dim the light using PWM, and we'll do a little bit of that as well. It's got an accurate clock and timer chip, which the Raspberry Pi does not have a timing mechanism, a proper clock timing chip, or built onto the chip. So what we mean by that is on the Pico, I can tell it to do something in milliseconds, right? 500 milliseconds, and it will do it in exactly 500 milliseconds. Right? If I tell a Raspberry Pi to do something in half a second, it'll do it in half a second, give or take, a couple milliseconds. And it's kind of like a regular computer in that way. The regular computers, right? They're like, I've got to show this screen, and I've got to pass this video, and I got to connect to this network. And at the same time, I'm asking you, you're asking me to time this light. I may be, maybe off by a millisecond or 2. But the Raspberry Pi Pico, just like the Arduinos, they have a timing chip that helps them make sure that it's accurate, right? And also, there's a temperature sensor built on board, so we can take the temperature of the board and do some experiments with that. Accelerated floating point libraries on the chip, and then it's got 8 programmable state machines for custom peripheral support, which we're not going to need to worry about that at this point. But basically what we're trying to say is, in a $5 package, you get a really nice set of resources to work with, okay? You are going to want to refer to this diagram quite a bit throughout the course. So if you have like a clipping tool, you may want to go to this documentation. I can copy the link is in the presentation, but I'm going to put this link in the chat real quick, and we'll take a look at these other links here in a minute. But you may want to take a clipping tool, right, and clip this out and then print it, right? And if you can print it in color, that way you can see what the different resources that it's taken up on. We are going to mostly concentrate our efforts, especially for the first couple of days, on the GPIOs, right? The green and black, which are ground, and then the reds, which are providing power. And mostly this one here, the 3 out, right? And then I think I have some of these diagrams. Actually, here's the pinout diagram. Yeah, that's nice. You can just print that. Can that just be dropped? All right, so maybe you can get it from the chat. I just dropped it in the chat. So yeah, print this out if you can, because you're going to want to refer to it as we go through the week. All right. So the wireless on this thing is 802.11n, single band 2.4, right? It uses WPA3, or it has capability to WPA3. So it does this. It has also looks like you can do a soft access point supporting up to 4 clients. It looks like we can actually create an access point out of the Pico, which I think would be fun to try. So somebody asked about the strength of the antenna. This has some more details. I'm not a wireless expert by any stretch of the imagination, but connected to the SPI controller. Let's see if it has a range. All right, so it's just saying right now it doesn't support Bluetooth, but it could at some point in the future. And it looked like this is the W pinout. I think they're going to be similar for our standpoint. There may be a couple of location differences, like the debug is way up here now. So if you have a W, you may also want to, let's go ahead and download that one and push that over there as well. So you can print this one as well. All right. And we'll add those 2 items to our documentation so that we have that ready to go. Awesome. All right, so at this point, let's see what this is the hat that shows the signal.
Hey, Carrie?
Yeah.
So it looks like, are they kind of multiplexing then on those pins? It looks like they have multiple functions because of the
Yes.
different coloring. So if you're going to
Absolutely.
use it for one function, then you would like use those pins with across the color, the same color.
Yeah, you would address them as you would just address them differently. Like, so if you're using SPI stuff, you're going to address GP. It's not going to be GP2 that you address. You'll be addressing SPI1 or SPI0. And when you connect things, right? And if we get into doing SPI, we usually don't do if we get to the LCD panel, we'll use SPI. So then we'll be able to see how that works. But yeah, so they all have, and like UART, like, so if I wanted to connect, right? If I wanted to connect a terminal session to this, I would use the first 2 pins, but then at that point, I'm not using them as GPO0 or GPO1. I'm using them as UART pins instead. So yeah, so they're multiplexing all these things. So every single one of these has something different. And then these pins over here, 34, actually 35, 34, 33, 32, 31. These are your analog pins, right? So analog 0, 1, and 2, and then there's analog ground, and there's an analog reference. So these can be run as either digital pins, GP28, GP27, GP26, or analog AD0, 0, ADC0, 0, or ADC1 and ADC2. Yeah, and then here's UX receive and transmit down here as well. UART, I'm sorry. So there's UART up here and UART down here. Yeah, so they're using all the pins for a bunch of different purposes. They're kind of maximizing what they could do with 40 pins. Good question. So this was a link that was shared by Mike. What the heck is all of this? Oh, does this allow you to you break it out and use terminals? Is that what this is gonna do? But how do you connect it? I'm just curious at this point. This. I apologize. This happens a lot. I'm gonna put that one on the back burner. That one looks fun. Looks interesting. So, and then also in the for the link to the WASTC page.
Yeah, Gary?
Yeah.
That's a hat. You just put it on top of your Raspberry Pi, like your B, and it gives you it has the lights will light up if as the pins are being talked to, and you can use these as the top things to put your connections in, but it has the LEDs to tell you whether or not the connection that you did
okay. So it's
is lighting up the right pin.
All right. So when you program it to go to say 4, right, and you see the light there, 4 lights up.
4 will light up if you're calling it. If 5 lights up, you went oops.
Nice. Okay, that makes sense. I like it. I had never seen that before. All right. Cool. All right. Excellent. All right, so why use the Raspberry Pi Pico? So I'm a community college instructor, right? So I teach community college courses. I teach CIS. Right? If you think of the stereotypical college student, right, and then drop that down a notch, you think of the typical community college student. And I'm not saying drop it down a notch from a intelligence standpoint or a attitude standpoint or a work ethic standpoint. I'm just talking that most students that go to community college are there because they're trying to save money, or they don't have a lot of money. And I know I work at a institute as a where I live in a state where we have I think I want to say, and I don't want to misquote it, but I'm sure we're probably 20% so around the poverty line, right? So we're not a rich state. We don't have a lot of um, population either. I think we may be 2.1 total. And our state is huge. Our state is like a fifth in landmass. So um, so we have, our situation is I want to make sure that my students can learn, and I want to put devices in front of them or components in front of them that are that they have a lot of options to learn a lot of things, but they're not spending a lot of money, right? So in this case, right, a board by itself is $4 to $15. You power it with a micro USB cord. Most everybody in the world, well, let's say most everybody in my state at least has a USB cord, right? And they could be purchased, in fact, sometimes the cord will actually cost more than the device. So I can get them connected to a device and I can teach them how to program using this really inexpensive device. Instead of, and I can teach them how to do that with a laptop or whatever, but the idea of that is like, if I tell you got to go buy an $800 laptop, or hey, I really want you to buy this, this kit that's $30, then I can teach you a whole bunch of cool things using the computers that we have at work at the classroom, right? So for me, cost is a big deal, which is the reason why I like to use the Raspberry Pi. I can teach an entire networking class on the Raspberry Pi. I can have them build DNS servers, DHCP servers. I can have them build wireless access points. I can have them build firewalls. I can have them build servers. We can do a ton of really cool things with the Raspberry Pi, and it's a cheap. It got expensive because it was hard to find. Right now, I know you can go right now out to Amazon, Villroast, and SparkFun and buy Raspberry Pis today. So they're more prevalent now than they have been the last couple of years because of the chip shortage. They are still expensive, but at $150 for an entire kit that does a bunch of different things, that's significantly less than, say, a $500 to $800 laptop. Okay, so my first thing in my mind is the cost. These kits, like the basic kit that I asked you guys to buy, is $30 to $50. Is that kit, and we can teach a lot of stuff with that kit. I'm mentioning the Pico Bricks Zero to Hero kit here because that's the kit that I love the best. I just got one the other day, and I think we'll take some time to go through that kit later today. Actually, I will show you kind of what the basic thing looks like, because it takes this idea of, I don't know, it makes it really fun. So let me show you what I'm talking about with the this hero kit. I gotta find my correct. Right, so this is the regular Pico here, right? And then this Pico Bricks. So this is the Pico, but then we've got, like, this is a motor controller, there's a relay, a temperature sensor, LED buttons, and they're all connected. There's the LCD screen, potentiometer, buzzer. I don't even know what that one is. An IR sensor, right? So we can do remote control. But this is all, like, it comes as this little kit, and we have all of these things that I don't have to do any wiring. It's actually connected through the black here, and you can actually break these off and then use these 4-pin wires so we eliminate the wiring component. But this gives us a ton more options. of more interesting things to build. This kit, which comes in this really big box, it's pretty big, right? It has greenhouse. It has a greenhouse in it that you can build. It has a robot platform that they can build. There was a couple other cool things in it, but you should check it out. We'll check it out more throughout the week, but ultimately, right, we're going to use the basic kit to get you guys started this week. But I'm really considering having my students do this instead, because then I know we can touch a bunch of different topics, and then they can intermingle all these things to make something fun out of it by the time they get done with class. But this is the Pico bricks, PICO bricks. I don't get any. This is just me sharing stuff I like. Right? So I want you to be aware of that. But those are cool. So that's the kit that I'm about to start recommending for my class. And I would rather my students spend the $120 and learn all the different things that we could possibly learn with that versus skimming it down. And I think, at $120, that's cheaper than a textbook in most cases. And I can use that kit in future classes, right? So they take this class usually within the first 2 semesters of starting, and then I can actually integrate the Pico or the Raspberry Pi, which we have in that same class. I can integrate those into classes later on. Okay. I'm hoping that you'll find as we go through this week that it's simple to use and easy to teach with. So that would be a second reason why we would choose the Pico. It's versatile, right? So we've talked about these things and we'll try to get to them throughout the week, but it has the GPIO pins. It can do SPI, it can do I2C, it can do UART, it can do Wi-Fi. Right? So it has lots of Internet of Things type connections. So I can connect to a bunch of different devices and make a bunch of really interesting components. Okay. It also has programming flexibility. So we have, we're going to use MicroPython, but we could use C, C++, I can use CircuitPython, Rust, Arduino IDE. Right? So if you're familiar with Arduino, and I think most everybody here isn't, you can use Arduino code and use it on the Raspberry Pi. C, C++ and Arduino code are almost the same thing. But if if you're teaching C, C++ courses in your curriculum, you can integrate the Pico into that and actually have them create physical devices, which in my experience tend to be more exciting than, say, writing code that just runs on the computer, right? So you have some options there. And then as you go through, there's other things that we haven't talked about on this list of things, but TensorFlow is one of those things that kind of keeps coming up as I research it. And then community, right? So there's a ton of great resources, right? And what I mean by that is if I were to just go, what? Research I was doing for my white hat hacking class, sorry. For those of you that know who Micro Center is, Micro Center Electronics, this is their headquarters. All right, so what I mean by that, Raspberry Pi, I gotta learn how to type. Pico project, if I just type in Pico project. 3 million results, 25 best Pico projects, 70 best Pico projects, 10 projects. Here's 3 different videos. There's, here's Raspberry Pi getting started with projects. Here's 20 more projects. There's 11 projects. Here's Tom's Hardware doing projects. Right, 12, the 12 best projects. Here's a bunch of books on Pico, right? So this is the one thing that you'll find anything Raspberry Pi based, right? You'll also find this if you do Arduino, like Arduino projects, right? You'll have the same type of thing, right? Probably twice as much. But one of the things I really like about why I like to use the Raspberry Pi and the Raspberry Pi Pico is the community. Like there's always a way for me to find an example that I can then turn into a project or into an assignment, right? And I can test this, I can test the tutorial online, I can rewrite it, or I can just a lot of times I'll have my students just do go to this tutorial and complete this project. And then I want you to modify it this way and show me that result, right? So what you'll find is that there's always um, options out there or examples out there that you can use, okay, for using the Pico or the Raspberry Pi, right? I'm going to step back to number 4 real quick, MicroPython. The reason why, so I have an IoT class, and the IoT class was based on the Cisco IoT courses that they had for a long time. Those actually are end of life next month. And in the last year or so, we've been kind of looking at things, you know, how can I modify my course to not rely on the Cisco material? The Cisco material has Arduino, right? And it has and I had already kind of switched. I'm going to bring up another website real quick. I had already switched off of using the Cisco material when it comes to the Arduino kits. I used the same kit that they recommended, and it's a really good kit. It's called the Tinker kit. Right, so this is it. It's got the Arduino, and it's got a motor controller, a servo, some motors, and then all these little devices that you can use. And there's this really cool document, right? This circuit guide. So it has 11 different circuits. It explains, you know, what breadboards are, explains how LEDs work, right? So this material is, you know, is really nice. And so if I was to stay with Arduino, I would continue to do this. Okay. Now, Arduino, if we go look at this is the photoresistor, right? So we're going to do a little photoresistor here. If I go look at the code, right? So this code is that C++. It's the Arduino code and how Arduino works, right? It creates a main loop. You actually do like all your settings, right? Your like your global settings first, and then you do a loop, right? The whole program just runs on a loop. You know, and this code here, we would do these assignments, and we would do all of these 11 assignments, and then we would immediately switch to the Raspberry Pi. And on the Raspberry Pi, we did everything in Python, right? So we would do this, and we would learn how all these things work, and we would use this code, right, which was C code, C++, you know, to kind of a mix and match of that kind of stuff. Oh, look, my timer went off. So we'll take a break here in about 30 seconds. And then I would switch them right into Python, right? And we would just continue Python. So one of my thinking for why I switched over to using the Pico is that I start them on Python right off the bat. We start on Python. Everything they do from day one is on Python. So I do Python as the microcontroller. I do Python on the small, you know, as IoT coding. And then we introduce Python into like the server class to have Python do something in the server class. We have Python do something, like we use it in a couple of other places throughout a system admin degree. So the idea of this was to say, hey, this device runs with Python. I can use Python from day one. My students get used to Python. They get used to writing these little scripts that do real specific things. And that idea kind of carries over into my system admin courses where, hey, we want to use Python to do this configuration. And then we create that scripts, right? We create a little script. So we're giving them a tool starting on right off the bat with this very first device, you know, learning Python from day one. So then over the course of 2 years with us, they understand Python enough to look at a piece of code and go, okay, this is what it's supposed to be trying to do. And I can make modifications and have it do this for me instead. Okay, so for me, affordability, the community for me should be number 2. Like, you know, if we're ranking these, I think the community allows us to find examples that are useful in the classroom really easily. And then the fact that I can use Python from day one is really important. Okay. So that my timer did go off, and I've been talking this whole time. I want to stop here because I think the next slide, right, we're going to actually get started doing the Pico, right? Oh, we'll talk about options in a minute. So we'll come back. Let's do like a 10-minute break, and when we come back, we're going to go over some options that you have as far as, you know, Picos. And then we'll get into actually setting up the Pico. All right. Are there any questions before we head out? All right. So there is one question I haven't. We can go over it real quick. What is the Raspberry Pi and the Raspberry Pi Pico? Are they the same or are they different? Well, they are different. Right? So Raspberry Pi Pico, this is a microcontroller. It's designed, we program it, we send the code to this device, and then it does that program over and over again until you unplug it or it runs out of power or you send a new piece of code. This is the Raspberry Pi. So this is the size of a credit card. Here's my phone as an example, right? So there's my, and I have a big phone, right? So I have a Pixel, right? So that's the Pixel XL, right? But it's the credit card size computer. This is a full blown computer. It has a quad core processor. It's got a gig of RAM. It's got HDMI video out, right? It can, this is a Raspberry Pi 3. This is not the latest version. This one can push 1080p. The newer Raspberry Pi can push 4K video from it, but this is the base cost $35. This base cost is $5. Okay, full functional computer, microcontroller. I program it, I send code, it runs that code. This one, I can also program it and tell it to run code, but it also is running an operating system. It could do other things. It can multitask. I can connect it to video. I can connect it to Ethernet. I can connect USB. I can connect Wi-Fi. I can connect Bluetooth, those kind of things. Okay, so fully functional computer, and this is what we're going to concentrate on next week in my IoT class. This week we're going to concentrate on the microcontroller. All right. All right. Then, so only the registration page comes up. All right. So then I think we should send. I'm wondering if I'm going to send, while we're doing the break, I will send an email to Karen and Laura and see if they can look into that for you, Lee. For everybody else, let's take a break right here. 10 minutes. Do what you need to do. Yep.
I just had a quick comment.
Yes.
In regards to the registration page, Lee, did you click on workshops? If you click on workshops, it should take you.
The only thing is when I hit that link that was posted in there and that was emailed to me, was all that comes up is not that. It's just the registration page, and that's all it says.
On the registration page up on the right-hand side, it says login.
Okay, let me try it one more time here.
Yeah.
I didn't see that. Let me see. Hold on here. Let me.
It's not really big, actually.
When I clicked on my link, I clicked on workshops and then it gave me the portal to enter the class.
Yeah, so that'll get you here.
Yeah.
He's not getting to this part yet.
No, I'm not getting to that. I'm getting to the registration. It has all the fields to fill out.
Did you
So
set up your password already?
I registered for the course and everything. So I'm just, yeah, that's the page I get right there.
Yeah,
Sign in up here in the right-hand corner.
In the email, there's a link to set up a password, and then after the password,
Okay.
at least this was my process. I set up my
Okay.
password and then I clicked on the link to access the class. And I just had a separate thing, Carrie. I can't access your notes. If you could check your email, I requested access.
Okay. Also, when you do log in, let me do this. Hold on. I logged out so we could see that page, and then I got to remember.
And we don't have to keep everyone.
Yeah,
for me.
everybody go take a break. I think I turned the timer on. I did it. Timer's still 9:59. You still got 10 minutes. There we go.
Okay, thank you.
Yeah, let's solve this problem real quick. I gotta find my login again. Okay. All right, so then once you get logged in, go to workshops. This is where you enter the workshop. For those that are having issues getting to the information, if you come to the link the course supplement, that should give you to, this is the Google Drive that is controlled by WASTC, not my personal drive. So it's the same exact stuff. But we'll cover that one more time before when we get back. All right. Right, we made it. Awesome. Are there any questions up to this point?
Hi, Carrie. Yeah, I had a question about different languages. Have you I understand there's starting to get to be some momentum for Rust. Have you worked at all in that, or?
I have not,
Okay, all right.
but I've seen some examples of it being used on the Pico, so that was why I wanted to make sure it was included, especially for those that are using it. I know enough Python to be dangerous. That's about it.
Okay.
I'm your stereotypical system admin. I know a lot of things, about that deep,
A
right?
little bit about, yeah.
And then I can understand stuff. So when I need to, I can expand my
Sure.
and programming is the bulk of my programming is this kind of stuff, right? Doing the IoT type of a programming things, or even PowerShell scripts and stuff. But
Well, one of the things that that seems to be pretty exciting is the fact that they're starting. I mean, this is just from what I've read a little bit, but that they're actually starting to use multi-core chips in these microcontrollers, which allow multi-threading and things like that, where you have thread safety and issues like that that are handled directly within Rust. It's more of a thread safe kind of
Right.
language, from my understanding. So it seems to be pretty exciting to me anyway, that you can do more sophisticated processing now with microcontrollers.
Yeah, and that's what's cool about this chip is that it's a dual core. It is a dual core processor. So, and I think that's kind of like how they have enough power in it to get TensorFlow to function too, which is an interesting deal. So, yeah, it's fun. It's good stuff. I mean, that's what this week is about, just kind of playing around, experimenting, learning. So it'll be fun. Anything else? All right. All right. Go shopping. So one of the easiest ways to kind of see what's out there, right, is to kind of go look at, maybe it'll come up. There it goes. So Vilroast, I have my students buy quite a bit of stuff from Vilroast because they have decent kits, and I think I sent out some links for Vilroast as part of this. But these are the two main kits that we try to use. This like a $40 kit here and a $45 kit. Trying to think the difference here. This has whatever that little thing is, and it's got the book, right? And the book is a free download, right? So, which we should probably look that up real quick. So that getting started with Raspberry Pi Pico. I think it's a hack base. Why would they do this to me? No, this is actually that we're gonna play with that a little bit later. Why is that book not showing up?
I found it online earlier too, but there's also another book about with C++ too.
Yeah, so Hackspace. So Hackspace is a magazine that Raspberry Pi publishes. And I'll tell you, the very first one that came out, they hooked me, the very first one, because there was actually designs on building a 4-foot trebuchet, like literally building a trebuchet out of plywood in the very first magazine, right? So they go beyond the Raspberry Pi. They do a bunch of other really kind of fun things. You can kind of see all these different devices that they have. And so they got these really cool articles. They have, they're on issue 67. Every single one of these you can download for free, right? So one of the cool things about these books is that they're usually like in the 100-page range, and they usually have tutorials in every single one of these magazines, right? So there's usually really neat articles about them, about things that are being built and made. There'll be some Python things, there'll be some C++ things, there'll be Rust things, there'll be Pico things, there'll be Raspberry Pi things, there'll be Arduino things, right? So it's not, the Hackspace one is not specifically Raspberry Pi based. They also have books, right? So these books here, these are also free for you to download. Okay. So FreeCAD for Makers, build a Raspberry Pi media player. Here's the book that we're going to use. So if you want a copy that you can't get from my resource or the resource, which, right? So this is the workshop. You go to the workshop. Once you get into the workshop, at the very bottom, this link to course supplement. The book is right here, this Raspberry Pi Pico Digital V10. That's the book that we're talking about. And you can just download it from there. Or you can come to this webpage, right? hackspace.raspberrypi.com/books, and you can get it from here. Download the PDF there. So those, if you do any kind of, here's an Arduino thing. If you're doing anything with IoT or anything that's maker related, these are really good resources to have, especially like for idea generation for your students. I use that a lot. The other magazine that Raspberry Pi does is called the Magpie. And they're at 130 issues now. So Raspberry Pi Microbrewery, we should pick that one up and try it. Oh, download on June 15th. Got 3 more days. But home automation, right? You can actually build out really cool home automation stuff. So a lot of students really get interested in that because they can run home automation utilities or controllers on the Raspberry Pi and then connect all their devices to it. Learn to code Python. These are just magazines, right? So magazine after magazine after magazine. Here's the thing about the Pico W. So those are really good. And they also have books. Right, so C and GUI programming, 2nd edition, this just came out. That's mainly kind of designed to be run on the Raspberry Pi. They may have some other things that they do with the Pico. I don't know. I haven't looked at that book yet. Every year they come out with a handbook, and that always has a ton of really cool projects. Retro gaming. So there's actually a book in here. It's an older one, but you build like a Galaga type game using Python, and the whole book is starting from scratch. And by the time you get done with the book, you can build that game. I use this book in my class, creating graphical user interfaces with Python. So I have my students use their Raspberry Pi to build graphical user interfaces. There's always beginner's guides. Those are really good. Trying to find here's a command line. That's a pretty good book that I've used that in the past. And I don't know where that one went. Here's learning to code with C. That's based on using the Raspberry Pi. If you teach a younger crowd, there's actually on the Raspberry Pi, you get the educational version of Minecraft. This is a book that teaches them to use Python to create things in Minecraft, which is totally awesome. This is Make Games with Python. I think that's the one. It's a little bit older, but from start to finish, it teaches you the physics that you need to get the devices to move the objects to move the right direction and stuff like that. So there's a ton of really good books. They're all in this. If you buy them in hardback, they're the 6x9, and they're hard to get in hardback. But you can get the PDFs, and I use these PDFs all the time, and you'll see how I use them today. But I just want you to be aware of these two. So magpie.raspberrypi.com and hackspace.raspberrypi.com. These are monthly magazines that Raspberry Pi produces. Each one of them 100+ pages of just really good stuff, right, to go through. So sorry, get sidetracked every time we think about things. So Vilros, right, here's the 2 kits that we like to use from them. SparkFun. So what I did with SparkFun is I just did a search with the results Pico, right? So you can buy the Pico from them. They also have these, right? So this is where Raspberry, by making the silicon available to other people, right? So this is the controller board that has the Raspberry chip on it. This one has an Ethernet connection, so $12.50, and you have an Ethernet connected Raspberry Pi Pico, right? Or the RP2040, which will do everything that we're doing today, plus it has this little piece. So these are where a manufacturer has gone in and added extra things. Okay. So there's really fun, like this one here, there's the Wi-Fi version of that, like, and then they've actually, SparkFun has put the chip on a little micromod board. So if you use the micromod stuff from them, which I don't use that stuff at this point, but and then there's another, yeah, so here's another board that uses a PIC. That's not using the Raspberry. All right. That's another one. And then Adafruit, right? So then Adafruit, if you've done anything Makerspace related, Adafruit has a ton of cool stuff. They have their own boards, right? So they got their the keyboard driver, right, which is using the RP2040. I'm trying to see what they do this specifically for their key build. So if you use their key products, and it's really tiny, right? So it's a really small board, right? So he's probably cut this in half. And then they also have the Feather, right? So if you're familiar with Arduinos and Feathers, Feather is a format that is real popular in the Arduino, and they've got an RP2040 version of that. So all I want to show you with these web pages is that this RP40 platform, which is what the Pico is based off of, is being used by lots of other manufacturers to put some really cool stuff out there. It's one of my favorite companies. This is Pimeroni. They are based in England. You can buy Pimeroni products at like, I want to say it's piusa.net or something like that. There's a couple of places that, and I think Adafruit even sells Pimeroni stuff. But Pimeroni, first thing, you got to love their name, right? Pirate, Monkey, Robot, Ninja. That's what it's based on. But these are products that they build, right? So they build a lot of add-on products. So these Pico, like this right here, is like you plug the Pico in and you can then control these LEDs. You've got these panels that you can do. They have these little, this is a white paper badge that you can plug the Pico into the back of it. This one here is a servo for the 2040, so you can actually control servos using the Raspberry Pi Pico. Tons of really cool products. Here's the thing that allows you to push VGA video out from the device. Badger boards, right? So this is, you can program badges with it. So just tons of really fun things that you can add to these, right? Got to be real careful or you end up with like me. I have like a Craftsman, a 3-foot tall Craftsman rollable, it's meant for tools, completely full of Raspberry Pi and Pico and Arduino stuff. But the idea of this is that you can see, holy cow, there's a ton of stuff that you can do, right? And a lot of it's just like you just search Raspberry Pi projects, and then you'll find a project that has a really cool thing. You just find the right device and you connect it to it. So Pi-Hut's another UK-based. Here's where you can power. So somebody asked a question about powering. So if you have like the LiPos that you would connect to RC cars, you can actually plug this is actually a Pico that actually can handle, and this is made by this is actually a Pimeroni device that can be powered by a LiPo battery. Here's a breakout board where you plug the Raspberry Pi Pico in. You have breakouts instead of having a breadboard. Right, here's the second one that's really nice. So they do a lot of really cool stuff like that as well. So the things that you can add to the Raspberry to make it more usable. And then Tom's Hardware has a really cool article about the best boards. So this is actually, and I wanted to show you this because here's the Pico, right? And then here's a bunch of boards that are created by other manufacturers that all run the same chipset, right? So they're still running the RP2040. So lots of cool. So this is a really good article to kind of run through and see why each device is made a certain way. Okay? But that's just a fun extra one. And then that did get me kind of go back to this this particular device, the SparkFun Pro Micro. This is SparkFun, so they're based out of, I want to say Boulder, Colorado, right? So it's a US-based company. They do their engineering there in Boulder, and most of the manufacturing is done there too. But they have this particular RP2040, and the reason I bring this up is there's another instructor, Katie Collada, who's been in a lot of my classes in the past, but she uses the Raspberry Pi, and she uses this, see this connector down here. So this is your typical, that actually looks like a USB-C connector, right? So they have a C connector powering the Raspberry Pico, this Pico board. But this right here is what they call a quick connector. I'm trying to find it on here. The whole reason for this board is the connector, so I'm surprised it's not showing on this list here. But what that allows us to do, they're not showing the pieces here. This is like an ecosystem that SparkFun has put together, and I think there's lots of other devices that will use it. But the quick QWIIC, I believe. So this allows you to, right? You can daisy chain. There's devices like, so here's the midpoint endpoints. I'm trying to find. Here's a shim. So this is an LCD panel, but instead, what you basically do is you plug the device into that Pico board, and you plug in that. So you kind of eliminate all the wiring that we're about to do, right? We're going to do a lot of wiring today. This is a little joystick that you plug in. That's a data logger. Here's a RFID reader that you just basically you plug in the wires. And I'm trying to find a picture where it shows them daisy chained. Yeah, like this. So you plug it into the board, right? And you plug that in. And so it does all the wiring for you automatically through all of these pieces. And this actually is a breakout board. So I could actually plug in a whole bunch of more. And I believe it's using, does it use SPI? It uses one of those two technologies to allow us to daisy chain up to 64 devices, I2C, right down here. 64 I2C devices. So I have a bunch of devices and I can just daisy chain them, and then I can address them individually instead of having to have individual wiring done for each one of them. So it's a really neat solution. She uses it for the Raspberry Pis because you can get a connector that works on top of the Raspberry Pi. But this is actually an RP2040 that actually has that connector built into it. So again, a lot of you, especially being new, you're like, what the heck are you talking about? So as we go throughout the week, a lot of this will start to make a little bit more sense. One of the things that I've been trying to do with my classes is to minimize the amount of wiring that we're doing. At some point, you've got to do some amount of wiring. But I was finding that in my classes, people were just overly confused about the wiring. And I teach CIS. I'm not teaching electronic, right? So I wanted to get them more to concentrate on the programming side of things. So this is a way for us to eliminate that wiring as an issue, right? I just plug in a pre-done wire from the device into whatever sensor I'm going to use, and I'm ready to go. And next week I'll go over the PiTops, which is the solution that I use in my classroom that eliminates wiring as well for the Raspberry. But just again, a bunch of different ways to do this, and all these links are in the presentation, and they're all there for you. The idea of this is I just wanted you to see that it's like there's so many options that you have. First of all, it's really easy to get overwhelmed by the options, which is why I kind of tend to say, let's do this kit and this book, right? Once we get done with that, we can look at what's interesting, and then we can go further from there. The only other thing that I did not put up there was the Pico bricks. Right, so here's the Pico bricks where they took the pieces apart and they're building a robot with it. But this is another way to get a bunch of really cool sensors. You don't have to do soldering. You're not doing any cabling. And then if you do break them apart, the cabling is the same type of cabling, right? They're just plugs. Yeah, you don't have to make sure the ground's in the right place. You just plug them in. They only plug in one direction. But then you have all these really cool devices that you can do, right? And then they have the little stands. So this is kind of how it would look in the classroom, right? I'm not a big fan of teaching I teach at the community college level. So if you'd like to teach using block programming, they have a block programming language that you can use. We would just go, in my class, we would just go right into MicroPython and have them roll from there, right? But this is that zero to hero kit. You see there's a greenhouse, there's a robot, there's this is a pan tilt zoom, and you connect a camera to it and you connect servos to it and you learn how to program that. So there's moisture sensors and a bunch of other extra pieces on top of the actual board itself. So this is the kit I really like, and I like it because I know most of my students this semester specifically, like they used a ton of these moisture sensors, and I had some people doing some security stuff. I had somebody attempting to get a robot to work, right? And this kit would have taken care of all of those kind of components. So, anyways, just again, showing you a bunch of different things that you can do, not that you need to do any of those things, but I want you to at least be aware, right? It's not about just this one little device that which we can just start with that one device and build up from there. Okay, I'm going to close all of those. All right. I think you can see already by the amount of web pages I like to kind of bring up and kind of show you. I think most of them I have linked created somewhere, and if not, what we'll try to do is I'll try to make sure that I get them all into a single document, and we'll put that document into the Google Drive. I'll make that editable. So if you find resources throughout the week that you like, that you think would be fun to share, I want everybody to add resources to that. That way we have a collective set of online resources that we can use after we're done with the class. Okay, so this is resource intensive. I think most everything I do is resource intensive, just because there's so many possibilities out there. So I will try to make them available ahead of time, right? Or in the case of like the Pico bricks, we probably should just add that to the list. So as we go, we'll add things. I am recording. My YouTube channel is here. So if you want to go out there and subscribe to that, you can see those updates as they come out. At the end of the evening, I will upload right before I go to bed, right? So I'll do the uploads right because they'll take a couple hours to get uploaded. So by morning, you should be able to see the link or the videos from today. Okay. I do have that Google Drive folder. We also have the WASTC shared resources. So anytime I add something to one, I'll add it to the other. So whether you can get to or not get to, you should be able to get to one of those two drives. If for some reason those aren't working, let me know. I'll drop folder files like I did into the chat, or I will just send you the files directly. Or I'll give you the web pages to go get the files yourself. I think 99% of everything we're going to use, other than my slide, which aren't that big of a deal. All the other stuff is more important. Those are all available online, and you'll see them as we go through the class, right? And then like I said, I'm going to use the Google Doc. We'll set up a Google Doc sometime later, and you'll be able to add resources as you find them. Okay, so just be aware of that. All right. So what time? It's noon my time, and I believe lunch is at noon Pacific time, right? So in an hour. Okay, so then what I'm going to do is I'm going to put my timer on for 60 minutes, right? So then when the timer goes off, it'll be lunchtime. So between now and lunchtime, my hope is that we can get everybody's Pico up and running and connected, and be able to write some code real quick before we go to lunch. Any questions up to this point? I'd like to kind of pause and make sure everybody's good. All right. So,
I'm not going to be able to do it because I don't have my Pico. I still can't find it.
oh
So
man.
I just
Okay.
ordered one. I don't know if it's gonna, so
Okay.
yeah. But I will just keep following.
Okay. Man, that sucks. But
Hey,
all right.
Carrie, I have a quick question. So
Yeah.
you mentioned earlier that you kind of moved away, I guess, from the Arduino because it was kind of based in C, and then when you went to Raspberry, everything was in Python.
Mhm.
What's been your experience with students in terms of programming in C? Is it been more difficult for them, or why do you like Python versus C, C++? Or can you
So
talk?
I can. So the examples that we were using, they just basically copied the code. So there was almost no programming. Right. So he's basically copied, like, here's the code that runs, run it over here. If you've wired it all right, it works. And then the only time they would have to do coding is if I make them do the challenges, which is what I tended to do because I'm not a big fan of just like, cookie cutter, follow this, right? Because then you always get the student that says, well, I follow the instructions and it doesn't work. Well, and then my response typically in my head, first of all, is, well, then you didn't follow the instructions. That's what I say in my head. What I do say then, well, then let's start over. Let's try this again. But um, so the transition wasn't that they were doing stuff in C and then had to switch to Python. It was that the code that they were given was in C, and it was structured differently, and they there wasn't any real coding at that point because all the examples that you find on the pages and the stuff that we were using, you just basically copied the code over. There wasn't any typing of it in. On the Python side, the way the book is set up, it's hard to copy the code out of the book. You have to type the code. So it kind of forces them to like learn how the code works, right? And then a lot of times, like you'll see when we do the examples, like I type the code and this is what we're going to put here, and this is how we're going to do it, and this is why we're going to do it. This is, and so they kind of get more into that. So it's not that it was causing a problem. I was just, in my mind, I was trying to simplify like process, right? So then if I'm going to create a project at the end of the semester and I've got a Pico and I've got a Raspberry, like everything's Python, right? I'm not trying to figure out how to get something from because I know on Arduino you can actually, if I'm not mistaken, you can actually you can flash it to run Python. So that's also, I mean, it could have probably easily gone that route as well, right? So we could have just flashed, because I know that in the Cisco material, there was one of the assignments near the end where you actually, right, you set up your Raspberry Pi so that you can run Python code you set up your Arduino to run Python code there. So I don't know. For me, I don't know, the simplicity of the fact that everything is the original idea of the Pico was that it runs Python and it'll run all those other things as well. But the original thought was it was MicroPython. We're in Python the whole time. I'm not trying to explain something in C and then the next week trying to explain something in Python. Everything's in Python.
I
Just
see.
kind of simplify in my mind that
Okay,
process.
thank you.
Yeah, no worries. Any other questions? We all good? Everybody back? Everybody come back for the. Everybody's still logged in. That's good. So, all right. So setting up the Pico, we're going to use the Getting Started book, right? We're going to use chapter 1. There's a bunch of stuff in chapter 1 that talk about soldering. We're not doing that part. So we're going to skip over that part. We are going to connect our Pico to the PC, and we'll do this. Don't have to do this now. I'll walk you through the whole process. And we're going to connect it, and we're going to install MicroPython. We're going to install a Thonny IDE. So, and I don't know that we said this in the the requirements, but I'm assuming since we're on Zoom, everybody has a computer that we could do this on, right? So if you have a Mac, I am not Mac savvy. So there are instructions on how to do these things on Mac, and how to set up Thonny, and it should work. But I'm I'm not going to be able to help you much. It's just something that me and Mac have never gotten along. I've tried. I've tried multiple times. So if you have a Mac and we run into a problem, I will try to help you, but I can't promise anything at that point. In fact, I can't promise we'll solve every problem anyways, but we usually can do pretty well. But there are instructions on how to set up so I'm going to assume, and that's what I tell my students. If you have a Mac, I'm going to assume you understand how to run your Mac, right? Like I still to this day, like the installation process is, I never know exactly what we're supposed to do. So, and that's, I've been using Microsoft since, I don't know, was it DOS 3.0, something like that. It was a long time ago. My first computer in school was an Apple II, right? You remember the green screens? But I used, I had Commodores at home, so I used BASIC and things like that. Anyways, sorry, get sidetracked. And then we're going to add Pico 0, which is a library, essentially. It's a Python library. We're going to add that to the, because I do want to kind of dig into that, right? And I'll explain what Pico 0 is and how that's, and you'll see the difference when we get there. But those are the plans for the next, say, hour or so. Get it connected, install Python, install Thonny, install Pico, and then make sure it's working, right? And I think at that point we can probably, we can shut this. I'm going to shut this guy down. Everything's hidden behind other things over here. Sorry. End the slideshow. Okay. Ending the slideshow. Now, we need to get the Pico digital book up. So we have the Pico digital book here. And for now, we're just going to we'll just look at the book itself, right? So we're going to use the book here to get started. I don't want to zoom too much because it'll get too big. Yeah, like that. Okay. That's still pretty small. Well, let's scroll through. So getting to know your Pico. This is the first chapter. So a lot of this is going to kind of repeat some of the stuff we talked about, right? Talked about amazing community, talked about how it's small. It does kind of explain, right, the connectors here. It explains the chip, things like that we've talked about a little bit already. The USB port, okay, the debug connectors, the underside, the fact that underside, which I haven't talked about, but the underside has, the underside actually has screen printing on it. So if we were to bring this up a little bit closer and zoom it, you can see that, right? It tells you GP21, ground, GP22, right? Those are, but the problem with that is like when you do this and you push this into the board, right? When you push it, this is not how we're going to run it. We're going to run it we're going to push this all the way down. You can't read those, right? So for us, doesn't really matter. If you are, right, if, a student is actually, and they want to plug wires into this, which you can, you could actually read off the bottom, but just to be aware that it's there. All right. And then like you get this big thing about soldering. So, right, so the question that came up earlier about soldering, this is going to explain it. You can see right here, right? This is the pins, and then they push them through the holes, and they're using this little putty to hold everything straight. And then you would actually, using a soldering, or you can put the pins in the breadboard like that. I'm going to show you. Here's the soldering iron, right? So you heat up the pin and the plate, and then you touch the solder, which is just like the meltable metal. All metals are meltable, I guess, but really easily meltable metal. And you basically add enough for it to create this little permanent connection. Okay. And then this is what you're trying to do, but you have to do that on 40 pins, and it's tiny. And if you mess something up, And maybe you can get out of it, maybe you can't. And then, I don't want my students ruining a device because we don't know how to solder. Because you can give it way too much, you can give way too little. But you can actually melt the contacts below, which causes problems. You can not get enough, right? Or you can create way too much and create shorts, right? So just, I think the question came up earlier about soldering. So this actual chapter does a pretty good job. Does a pretty good job explaining kind of the process, right? So for the question that came up earlier, that's a really good place to go. What we want to do is we're going to go down here to page 16. And we're going to talk about, I'm going to actually do it this way, because then I can fit it to this page. I can zoom to that side. Yeah, that's better. Okay. We're talking about installing MicroPython. Okay. So what you need for this is we need from our kit, right? You really only need the Pico and your USB cable. I'm going to leave mine connected, right? But I've got a micro USB cable that came with my device. Okay. Those are the only things we need right this second. We'll talk about the other kit, the rest of the kit, when we get to the point where we are ready to do physical computing. Now, I am going to say probably best that we grab the breadboard, right? So if you have a breadboard, if you have a half-size breadboard, that's fine. If you do have a half-size breadboard, you're going to want to put the Raspberry way up near the top there so that you have room to do stuff. If you have a full-size breadboard, then this is probably still fine to do this. So what you want to do is you can take your Pico here, and it looks like in mine they line up on the third row, right, of each side of this, right? So the third row, the pins do. You can see the pins right there. Okay. And then I'm going to kind of put my fingers on the edges on top and bottom here. I'm not going to press down there, but top and bottom, I'm going to slowly kind of press this into the board, right? You see I'm kind of pressing into the board. I'm going to try to do it as even as possible because I don't want to really bend the pins. But I want to push it where it's all the way seated, right? Yeah, there's not really, it's hard to see that with this. It's kind of blurry, but see how it's seated all the way into the board there, right? That way then we're done with that. We don't have to mess with that. This gives me 2 pins on each side that I can plug in, right, and connect to other devices. It also kind of keeps me from possibly bending my pins later on, like if I have it on the table, right? So we're going to do that. At some point, I might just tape this down. We'll see how it goes. But so that's the plan. So I would take your Pico and slowly, right, using the edges there, push it into the board, right? You want to leave yourself 2 rows on both sides, and you want to make sure that it's seated all the way down on all 4 corners. Okay. So that's the first step. I'm gonna get that step there. And this will probably go right about there for future. Okay. So that's going to be the first thing, right? You see how it kind of lined up there, and we're just going to push using the edges. All right. Now, on the board, there's this little white button right here. That's called the boot select button. Okay.
Carrie, before we
Yeah.
go on, if you seat it all the way down like that, and then you need to take it back out, can you just like use your fingernails or something to kind of pry it up again, or how?
Yeah,
do
you could. I use something like this, right? And I do a little bit under the edge, a little bit, right? And I try to get that same kind of idea. I want to go a little bit at a time. I don't want to, if you yank it like that, you'll bend these pins down here, right?
Okay.
So whatever you do, just, I just use like a lever. So like technically you probably could use a screwdriver. This is plastic, right? So if you have some kind of little plastic device like that, that's what I would use, right? Because metal on metal may scratch something or cause a short. But then, yeah, so you take it off like that. So, because what you do if you were to pull it like that, these pins down here would just end up kind of, at little angles. Okay, but yeah, so I used not really a fair comparison, but I use that, right? So I'm looking like I have a chopstick may work too. Like I could kind of pry that up underneath there, right? Something like that.
Okay. Okay, thank you.
Yeah, no worries. Okay. So then we'll go and do that again. I'm just gonna line that up, a little bit of a press, a little bit of a press, kind of work it in slowly and get it nice and seated, right? Seated on all 4 sides. Awesome. All right. So I would, in our case, I would go ahead and plug in your USB adapter to your computer, right? So the other side of this is plugged into the computer. And I've got my breadboard and I've got my Pico. Okay. On the Pico, there is a boot select button right there. Okay. For this first boot, and it kind of says this right here, hold the boot select button on top of your Pico. Then while holding it down, connect the other end of the micro USB cable to one of the USB ports on your Raspberry Pi, right? Or other computer, right? So you're going to make the connection while you're holding that down, right? And the reason we're going to make that connection, let me go ahead and bring up my so here's my file manager. Okay. By holding down the boot select button, it should launch this as an attached USB device. That's the plan. Okay. So we're going to press and hold the button, which I'm doing up in the right-hand corner, which I've covered up. That's all. Good job, Carrie. Press and hold the button, and I'm going to connect my USB. And you can see on the left-hand side, I've got an RPI-RP2. Right? So that is the file system on the Pico. All right. I'm going to pause there. So those that are working on this, I'm hoping that we get to this point. You got it connected to your computer. You held down the boot select button while you were booting, and you got this folder, which if we open, we should have 2 files. We're just pausing to make sure everybody's at that point. All right. And then once you're here, you're going to just launch this index.htm file, which is just a link out to the documentation that we looked at earlier. Actually, we looked at this documentation, so you understand. We looked at this, right? This is actually to the Raspberry Pi documentation for microcontrollers. Okay. So before we go any further, right? So we want to get into the information support about the Pico W. We could use this, right? And that kind of gets us to that explains the family. We stopped at that point. There's a debug probe, right? That's the pinout design for us, that kind of stuff. There's links to data sheets. There's links to right down here. There's the C++ SDK and the Python SDK. We're going to use the Python SDK in a couple of minutes, right? But just to kind of get an idea of what's here, there's information here about the RP2040, right? The actual device itself. So if you are in a place where you can do your own circuit designs and things like that, you could build your own. There's a little section on the debug probe, which again, I've never had to use at this point. There's a piece on MicroPython. There's a piece on the C++ Right? There's product information. So this is the compliance document. I think it also has well, this is on all of their stuff, right? So this is on all of the Raspberry Pi stuff. There's some tutorials and other things that we're not going to get into at this point, but just be aware there's also forums, there's data sheets. Data sheets will give you like the dimensions and everything of it. So if you wanted to, do a circuit design, or if you wanted to do like to build a board that you could plug this into, that kind of thing. Okay. For us, right, what we're going to do today is we're going to go to MicroPython, right? So the MicroPython is going to allow us to actually drop MicroPython onto the Raspberry Pi Pico to allow us to program the Pico. Okay. On this page, right? So that you can see there's a MicroPython wiki and forums available if you need to get to that. And if we run into like a problem with a programming question, we'll probably hit those up. There's also this getting started with the Raspberry Pi Pico. There's an official guide. I think that this is the online this is the book, right? So that's how you get a link to the book. There's also a link to which we didn't use. There's a link to an online tutorial, which we'll go through a little bit later as well. Now, what we're going to do is we want to drag and drop the MicroPython component. So depends on which device you have, right? So I am, right, which device do I have? If you look at this right here, based on what we talked about this morning, which device do I have? Do I have a Raspberry Pi Pico, or do I have a Raspberry Pi Pico W?
Just the Pico.
Just the Pico, right? I'm missing the wireless, the wireless right here. Okay. So if you have a W, then you're going to select the second one. If you have a Pico, you're going to select the first. I'm going to select the first one. And what that's going to do is download this UF2 file to my Pico, or to my computer, right? It's on my computer, right? And then what I need to do is I need to drag that file onto my Pico. And when I drag the file onto the Pico, it will disappear from my file manager. And that's essentially putting MicroPython on the Raspberry Pi Pico. Okay. So now I don't have, I go back over here, I do not have that file, that folder any longer. Okay. So that's the first step. That we just connected the Pico to our computer as a USB drive, and we installed MicroPython. We dropped MicroPython onto the device. Okay. The next thing is now I need to be able to communicate with the device, right, and be able to program the device. We're going to use Thonny, which is, there's a link right here. So this is where I grabbed the Pico UF2 file from, and this is the link for Thonny. Right? So the link to Thonny is going to take us out to Thonny. This is an IDE. So if you're familiar with Python, right, this is a real basic interpreter, right? Build basic internet or development environment. It's good for beginners. My students have taken to it pretty easily. And everything we know from the Pico standpoint and connecting to this Pico works with Thonny. So I know it works with other IDEs as well. However, I don't want to, especially with everybody being new, and my students have never done this. Most of them have never touched a microcontroller before. I don't want to introduce, something spectacular. If you have, other favorite IDEs and you want to see if it works, you can, research the IDE and in the Pico, Raspberry Pi Pico, and see if there's something special you need to do. For this course and for this workshop, let's just use Thonny. Even if you have a favorite IDE. So, Mac, Linux, and Windows 4.02 is the latest version, right? So for me, I'm on Windows, so I highlight Windows. I'm going to go ahead and do the 64-bit version using Python 3.10. Okay, so I'm just going to grab that executable. You see a newer version? Are you on the Mac side? 4.11. Oh, Windows 11. Maybe because I have 10. It might be that's interesting, yeah, because this is their page, right? So nice, okay. Newer version. I don't think we're going to run into any issues. I know you have to have a new version of this program or Thonny for this to work. So you get an executable that downloads. Simply going to click the executable and install. I'm just going to install for all users. I'm the only user on the computer anyway, so it doesn't really matter. Yep, go ahead and do that. Accept the agreement. Put in the default place is fine. Thonny's fine. I'm gonna go ahead and create a desktop icon that may make it easier for us today. All right. So as this installs, so this is installing Thonny, which again is it's just a development environment. It's going to allow us to type in code and send the code to the Pico. Hit finish. All right. I'm going to move these pages off to the side real quick. I believe that's going to set the icon. I'm going to move this icon to my other desktop so I can launch it easier. I'm going to double click the Thonny icon. And so this is the Thonny development environment, right? So you have your interactive shell down here. You have your programming shell up here. You have your new, so you can create, multiple, like we can have multiple programs and just one run at a time. Then we'll do that a lot over the next couple of days. If you've saved a file, you can reopen the file. This is the save button. This is the run button. So if you have a script up here and you hit run, it'll run the script and you'll see the result in the bottom. Before you run a new code, we always like to hit the stop button so that we stop whatever's going on and we get back to something that looks like this before we run new code. And you'll see me do this a lot. I'll change a piece of code and I'll hit start, forgetting to stop the program, and it'll give me an error. But just to be aware, right? So real basics. We're not going to, get into configuring the IDE or anything like that. I am going to try to drop this into the corner down here. So this hopefully. What I think I'll try to do now at this point, I don't want it moving around on me. Okay. I taped it to my desk. so it would be here. All right. So try to do it this way. We have the instructions over here on the left. I've got the interpreter down here, or the development environment, and then I've got the actual device. So you can see the device and anything that we do with that device. Okay. So at this point, we have done several steps of our PowerPoint presentation there. So we'll bring this back over real fast, right? So we have connected it, and we have installed the MicroPython, and we've installed the Thonny, right? What I want to do, I'm going to jump out and grab this. I'm going to copy this link into the, so this is going to get you Pico 0. So this is the Pico 0. So this is a library that was created. And what they've done is with this library is they've simplified the programming for this. And if you're familiar with the Raspberry Pi, for those that have been in my previous classes, there is a GPIO 0. GPIO 0 is another library that I almost use exclusively in my classes because it just makes the programming easier. It simplifies, connecting to things, making things work. And they've done the same thing here for the Pico. So I want to play with that and test that today. To install this, we're going to kind of scroll down to the install and getting started guide. And we're using Thonny. And on Thonny, so this is one thing I haven't pointed out yet. So with Thonny installed, right down here you see Thonny. Right down here in the corner, you can see I'm actually connected to my Pico. Okay, if I click here, I can run Python local, and that would be just running like a Python interpreter on your desktop, and you type in code and run the code, and it runs on your desktop. In this case, I'm selecting and it pre-selected it for me because we had just installed MicroPython on the Raspberry Pi Pico. It's connecting me to my Pico. So any code that I send is going to actually run on the Pico. Okay, it's not running on my local machine, it's running on this machine, right? I will see the result on my local machine, but it's running on the Pico. Okay, so I'm connected to the Pico. And that's kind of what this first little instruction on this installation of the Pi Zero or the Pico Zero was talking about, right? Right here, talking about making sure you're connected to that. So to install Pico Zero from Thonny, select Tools, Manage Packages. Right, so I've never done this, so I'm kind of going slow about making sure we walk through the instructions. All right, so Tools, Manage Packages. I believe we can install from PyPy. So we want to do, we just look at Pico Zero. Search on PyPy. Right, and then I guess we click here, install. Just click on there, install from PyPy. That didn't work the way I wanted it to. Search. Oh, select Pico Zero here. Then we do install there. The package from you wanted. Install from the requirements file. Like I said, I've never installed this package. Am I missing something? Oh, at the bottom. Okay, thanks. If I at the bottom of Bonnie or this page, Pico. Oh, install right there. Nice. I'm sorry, I was missing it. So this is just going to basically bring that library from the repository online and drop it onto this machine, so it's available to us to actually call the classes from that library. Got to do a little bit of house cleaning there. It looks like installing pip, updating pip, removing other things. All right. So then it gets to an uninstall, which I'm assuming that means we got it installed. So in the way we can test that, I'm gonna go ahead and close this. And this is, no, that's not the document I want. Document I want. We're not doing a manual install. So just quick, if I were to copy and paste this, you don't need to do this. I'm just, well, you could, I'm just testing. So if Pico Zero is not there, it'll give me an error on this, right? I'm not worried about an LED being turned on or turned off or anything like that. Right, so I ran it. I'm not getting any error, right? What you are seeing going, right, is my LED right there is blinking, right? So the Pico LED, which is the actual onboard LED in the corner here. So this code, just real quick, makes sure that this is just me testing to make sure that Pico Zero was installed. So from the Pico Zero library, import Pico LED. This is code that will allow us to connect to this device. From time, import sleep. We'll talk about that. U time is what it actually uses. And then we're doing a while true loop, which is a forever loop, right? And we're saying turn on the Pico LED dot on, turn on the LED. We're going to sleep for 0.5 seconds. If you're not familiar with Python, sleep is a pause, right? It'll do whatever it was doing. It'll just keep doing that for that amount of time. So stay on for 5 seconds, 0.5 seconds, then turn off for 0.5 seconds, and then turn back on for 0.5 seconds and off, right? So we're just going to continually do this loop right here. And you can see that happening right there. So that's good. That lets me know that that is functioning the way it's supposed to function. I'm going to hit stop. It ended in the on state, right? So just so that we're familiar with what was happening there. All right. Now, so at that point, I'm comfortable that this has been installed, and I'm not going to worry about that for a little while. How's everybody else doing? Do we have, are we connected, right? Were we able to copy over the micro Python U2F file? And were we able to install Thonny and connect and have Raspberry Pi Pico here in the corner? And were we able to get the Pico Zero installation through the tools manage packages? And in my case, we just ran this test utility to make sure it worked. It works. We can see the LED is on. All is good. Is anybody not there or not comfortable getting themselves there in the next couple of minutes? On the left,
I had
go
a
ahead.
quick question.
Yeah.
So I know with a lot of different IDEs, if I hit Control question mark, that'll comment out the code. Is there a quick? It doesn't seem to work with Thonny. Is there another kind of quick way to do that, or do you have to?
Each line, if you put a hashtag in front of it.
Okay,
And
so
I don't
there's
know.
not quick highlights.
I don't know if
Control
there is.
question mark. It'll do it on other IDEs, but okay, if it's not there, it's not there.
It might not be there because it is. I mean, it is kind of designed for beginners. Oh, here, if I Alt 3. So I highlighted a whole section and hit, you could hit Alt 3, or I went to edit and comment it out. And I can also uncomment. Awesome.
So if you
Great
wanted,
question.
you could just, if you were like worried that you didn't want to burn out your LED because it was just going to remain on for a while, you could just like comment out some of your statements and then turn it off real quick, right?
You could, yeah, you could actually take that, paste it there, delete all of this, and then run this. So I just hit stop, wait for that to come up, hit play, and it should go off. Yeah. I don't think it's going to burn out because in about 10 minutes, we're going to turn it back on and off. So, but that's a good question. Like, oh man, because like you don't want it stuck that way. Like, or if I have, a bunch of LEDs and they're all doing something funky. Yeah, the easiest way for that is just to kind of do this, right? You turn it off. And this is, to me, this is the easier way to do this. We're going to follow the instructions and show you kind of the normal way to do things. And then we'll go and play with the Pico Zero stuff again. And you'll see some of the differences, right? I find it simpler to deal with. Good. Other questions? So Pico Zero, are you doing one word or 2 words? Tools, manage packages. Pico Zero is a single word. It's going to give me thumbs up on installs, thumbs down if you're not. Are you good? Just some kind of indicator that I know we're okay.
I haven't started mine yet, but I will over lunch. So
Okay.
I've got a Mac. I'm working on a Mac, so I'm just trying. I got Thonny installed right now, so I'll just pick it up from there.
Okay. Oh, good.
I'm just
good,
watching
good.
it though.
No worries. I don't want. Yeah, I would hate to lose somebody right off the bat, right? That would not be fun. All right. So Mike, where are we stuck at? So I'm scrolling through the book. Like we did the piece where we copied it over, right? And then I jumped down, way down. Okay. Awesome. Right, so the file disappears. We've already seen that happen, right? So then we're already on to chapter 2. So chapter 1, literally, right? What we need to know out of chapter 1, because we've already kind of talked about the Pico. Chapter 1 in this book, right? And if you're doing this in class, I have my students read all of these chapters, right? And I expect them to have read stuff and not just do the code, which is, that's asking a lot to actually read and not just type in the code.
Where are we gonna get through? Which chapter are we gonna get through for tomorrow?
Which chapter?
Yeah, where do you want us to be like before we come into class tomorrow?
Oh, you don't have to do anything this evening.
Oh, okay.
We'll get wherever we get today and we'll start next tomorrow.
Okay.
Yeah, I got the code is fine. I mean,
Okay.
seeing everything like the code, and it just didn't light anything up.
No. So and you're using the Pico 0 and you didn't get any errors.
Oh, I got a lot of errors.
Oh, did you install Pico 0?
Yeah.
Use it, tools, manage package.
That's what I thought I did.
It should show up like this now, if it's installed.
Okay, where the hell is that?
So on Thani, tools, manage package.
Manage package.
And if it's listed here without you doing any searching, then it's installed. If it just says install, then we need to install it.
Okay, let me click on it again. When I click on it again with under install, it just says uninstall.
So click here and it gives you that, like this information here.
I see a whole bunch of stuff.
Yeah. So then it looks like it's installed. If it's on that list, it's installed.
Yeah.
But then why would it give you
most recent last call, line 1 module, LED blinked up. Okay.
Oh, can you do a screenshot and throw it into the chat so I can see what's going on?
Sure. Hang on.
Everybody else okay? We got some confirming after lunch. We got some check mark. Had to reinstall MicroPython on the Pico, reinstall Pico. Okay. Okay. So there was some hang up in the installation. Which could happen, but it's so easy to actually get a new one. That's not that, pretty easy to start over.
Hey, Carrie.
Yeah.
Hi. Where did you grab that code from? What screen?
This code?
Yeah.
That code was actually, so this is on the Pico 0, like up here is where we did the install. I just scrolled down a little bit and grabbed this first set of code just so I could see if it worked or not.
Okay.
I just copied that code right there.
All right. Thank you.
So you guys are going to want to probably bookmark this, this Pico 0. Let's go here. I'll throw this into the chat real fast so that everybody has that link. This is the Pico 0 documentation, and we'll deal with that documentation later. Donnie was on the other part, so we should be good there. Okay, excellent. All right. Yes, no, maybe so, kind of, sorta.
Yeah, I had a question. I'm just installing Thani, and it says, do I want to do the standard installation or the Raspberry Pi simple installation?
That's weird. Are you on
I'm on a Mac, so maybe that's not normally.
I would do the standard.
Just standard? Okay.
Yeah, I would do the standard. I think it hold on though.
All right.
I wonder. So installer does it?
It says initial settings, and then there's so it's English, and the language is English, and then initial settings standard, and then the other option is Raspberry Pi simple.
So that gets me thinking, like, is it
Does it like maybe preload libraries for Raspberry Pi or something like that? Maybe?
Yeah, it might. I wonder, I don't know. I don't know.
Well,
I
here,
wonder if you
I'll,
want,
I'll just go and do a little, I'll just try to look it up on Google and see and ask and see what it.
yeah, what that Raspberry Pi version is. I'm wondering if it's like a version specifically designed to work with the Pico, or if it's designed to work with the Raspberry, or
Yeah.
like,
Okay.
because I think because you're running a Mac, I wonder if, because I know there's a couple of ways for you to plug like a Raspberry into a computer and actually be able to like use it like a microcontroller. And that may be that what that is. I'm not sure. I've never run into that before, so I apologize.
Okay, that's okay. Thank you.
Well, if you find the solution, please let us know so we can. Otherwise, I would probably do the standard unless you can see something that says specifically, you know.
Oh, okay.
And what do they call it? The Raspberry Pi is like a version, or
It just says initial settings. So there's standard, and then there's Raspberry Pi simple. I mean, I guess it won't be. It probably won't hurt to do it either way. I would imagine probably, but here, I'll just do a quick internet search. Hold on.
yeah, I'm trying to see if I see anything. Yeah, they just all the instructions just download the the relevant files and just get and install them. Doesn't say what the simple version is. I'm wondering if it's because your machine's Linux or a Mac, if it's seeing it for some reason like a. That's weird. All right. How to install it on Mac. Install that package, open it up. Somebody made instructions and it literally, it shows the Thonny, you download the package and it shows introduction on the install and it shows completion. It doesn't say anything in between, like the license page, the destination select, installation type. I think it's just the standard version. That is weird. Yeah, so it looks like on the Mac, you may have to this little piece down in the bottom corner, that MicroPython may or may not automatically select. And if it doesn't automatically select, you can find it here, or you have to configure the interpreter. And I'll throw this over there, but it doesn't help us with our current question. But it does have a little bit more detail on the Mac side on the installation. I would go with the standard for now. I don't think it's going to be
Okay, I'll give it a try.
awesome. Okay. So then we redid the steps and we got it working. That's good. Mike, are we still getting errors?
Yeah.
What is the error?
I put something in the chat.
Okay.
That's part of it. I made it, expanded it so I can get the whole thing. One of it's oh brother, Windows, and let's see it up the whole damn screen. No module named machine is one of the things. From machine import pin, and there's no module named machine.
Oh,
the
you
machine
started already. Did you jump into chapter 3 already?
No. This is just the LED.
Okay.
And it and I'm looking under.
Did you have a capital M instead of a little m?
I don't have machine in as the
Oh, really?
the
You're using the from Pico in your code.
Yeah, the LED blink dot py doesn't have anything in it that says machine. It just has the Pico 0 and from time you get the Pico LED and sleep.
Okay, so the next question is, where did that code come from?
That's what I copied from what you had on the screen.
Did I miss a blink somewhere?
Yeah, it.
So if you were to do, can you see what I have on my screen right now?
Hang on, I got a whole bunch of crap up
No
the
worries.
way here.
That's
Yeah.
not
Let's see. Boom. Okay. And you have yeah, I can see that. Pico
Okay.
from Pico.
Do exactly that. Let's see if that.
Okay.
So I would just
All
use
right.
just these things, just type them in. What it should do is it should turn on the LED like this.
Okay, let's
I'm
see.
wondering if, go ahead. Oh, the other thing is make sure down here in the corner, you have MicroPython, your Pico is showing up and not the local.
That's probably what it is. Yeah, that's what it is. It's
Okay.
local.
Yeah, so it's not, the machine is actually is code that's actually on the Pico,
Yeah.
and the machine won't.
Oh,
And so what's happening? Pico 0, the library is calling machine to make the
right.
LED work.
Yeah.
But
So
machine, if you're not actually connected to the Pico down here, then it won't actually be able to pull that library.
okay, so I want to
So to change it, you should be able to just click on that and then hopefully pick the Pico. That was, I mean, if it should be able to be connected to your computer, should be able to see it.
Python 3 Microsoft. Running what kind of interpreter? MicroPython, which one? Raspberry Pi Pico.
Yes.
There we go. I said, what are you doing, dumb shit? Okay, so I'm see if I can get everything all plugged back in the way it's supposed to be. This is plugged in here. That's plugged in over there.
So
Back
Tina,
end.
okay, yeah, while you're doing that, Tina, I'm using a Lumen document camera, like a DC, I want to say DC 93, something like that. These work really well. We have them in the classroom as well. Like, so it's like I can bring this up really like that, and students in the whole classroom can see the wiring that I'm doing. So it works really well online. It works really well in the classroom. But Lumens, Lumens. I would pick it up to see, but then I'd have to readjust everything. So see what the model is. Awesome. Yeah, no worries.
Okay, now let's see.
All right. For everybody who's got it working, I want to make sure everybody's good, right? Because then as soon as we start rolling, if something's not functioning right, it just makes it really painful for that individual. So I want to make sure that we get this kind of connection working before we progress. And I know we only have, it looks like about 4 or 5, well, looks like 7 minutes or so before lunchtime. For those that have it working, if you want to go ahead and you can start looking at chapter 2 there, right? So Chapter 2 is programming with MicroPython. It's going to do, you're going to do some basic Python programming. We're not doing any physical computing at this point in time. We're just going to run some code. If you can, this kind of explains you can see my interface is a little bit different than this. I think most of ours are going to have a little bit different than this. This is actually showing the simplified. Actually, this may be the simplified Raspberry Pi version because you can see switch to regular here. So the regular version is probably fine. But this kind of just explains the pieces if you're not familiar with what an IDE is. And then making sure that you're connected, which is that second part, connecting Thonny to Pico. Right, and that's going to be down in this bottom corner where we keep clicking to see, am I connected to the Pico? Am I connected to local? The instructions on the Mac side, we're telling you to configure the interpreter, which then allows you to select the device that you're going to connect to. If it's not picking, and one of the reasons why we use Thonny is because it picks up automatically where this thing is at. Sometimes you don't, and you may have to go to Device Manager. So that's not a normal thing to have to do, but in Device Manager, if you look up your ports, you can see, if I were to unplug the Raspberry right now, right, the USB COM4 would go, this COM4 would go away. And then I would know that that's where my device is plugged in. Right, so there's some basic troubleshooting to kind of think about. So right down here, it also talks about if there's no Raspberry Pi Pico interpreter, it's only available with the latest versions, right? So unless you have I have that latest version. This is why we did the install from scratch today. There's also the switch to regular mode. So there's some information here. This is on page 23 of the book. That talks about some options that you have to get your Thonny interpreter or to be able to see the Pico. Okay. And then, like always, when you're doing any kind of programming, every time you start programming, they want you to do, print hello world, right? I'll leave those there because we're not going to run that. But this one here, they're going to ask us to go to the three carets, right? This is your interactive shell. So again, if you've never programmed, and I didn't ask that question at the very beginning, so I apologize if I'm over explaining things, but interpreter right there, are the interactive shell. This is like, I'm going to type a line of code, and when I hit enter, it runs the code automatically, right away. Okay. So in this case, if I just print, right, hello world. Quotes, right? So, well, that's not what we want. Hello worlds. Right. So print, parenthesis, quote, hello world, right? Quote, and then parenthesis again. So Python is really, the syntax in Python, right? Uppercase and lowercase matters. There's some places where spaces matters. There's places where they don't matter. And as we go through, I'll explain those things in our simple programs that we're doing. This is the print statement. So that's basically saying is I want you to print this onto the screen, right? And it has to be in the quotes or in the parentheses. And then if you want to have a string value, like any kind of text value, you put those inside a quote, right? So hello world, if I hit enter, it should respond back with hello world, okay? So we've written our first Python line of code. And that's running, again, that's running on the Raspberry Pi Pico. You can see right here, it's even telling you I'm on the Pico, right? There goes our timer. We still have about 2 minutes left before lunch. I think if you want to continue that, I think we'll stop there. We'll continue this piece afterwards. If you still have an issue, let me know. Maybe we can try to figure them out over lunch. Because I don't want to get into lunchtime. And then the other thing I need to let everybody be aware of is that I'm pretty sure my grandkids are going to show up here in the next hour or so. Hopefully it's over lunch and it won't be interrupting the class. But as soon as they show up, we'll take a break for a couple minutes. I'll go play with them or go at least say hi. We're gonna go play tonight. I think we're gonna hit Dave and Buster's or something fun. But yeah, they're on their way from out of town, so pretty excited. Otherwise, are there questions at this point? We're at lunch break. If you're good and you're ready to go, and right, you've printed "Hello World," we'll stop at that point. I'm gonna leave my screen as is. I will stop the recording. So Mike, remind me when we get back to start recording again. And hopefully everybody's there. So once we get back, hope we can solve any kind of real quick issues that we're connected with connectivity, and then we can get rolling onto getting some coding done. I think with the time that we have, I think we're going to be able to. We're going to probably go one chapter further than I was planning on today, which is fine. So we can make some progress through the book. My plan is to get through the entire book, right? We got this entire book, 138 pages worth of goodness. I want to get through that, get everybody comfortable with the Raspberry Pi Pico, physical computing, MicroPython, and then we can kind of expand into some other more advanced topics at that point. All right. So we'll put a timer on for an hour, and we will regroup and come back and keep on trucking. 1 hour timer. We will see you in an hour.